Welcome to Everyday Explained, your daily 20-minute dive into the fascinating hows and whys of the world around you. I'm your host, Chris, and I'm excited to help you discover something new. Let's get started.
Okay, let's jump right in. Today we're tackling something everyone gets, but maybe doesn't think much about. Goosebumps.
Right, that weird, sudden, kind of prickly thing your skin does.
Exactly. It seems so minor, doesn't it? Just happens. But why? And, it's not just about being cold, is it?
No, not at all. That's what makes it interesting. You get them from music, movies, strong emotions.
Yeah. So we've looked at some research papers, some health explainers, trying to really get under the skin of it, so to speak.
Pun intended.
Huh, maybe. But yeah, the mission today is to unpack the science, the history, maybe some surprising new stuff. Really figure out what's raising your hair and why it even matters.
And maybe have a chuckle about our slightly odd primal brain wiring along the way.
Definitely. Okay, let's get started. So first things first, what are goosebumps, technically?
Well, the proper term is piloerection. Piloerection.
Piloerection, okay.
And it's fundamentally an involuntary reflex. Your body just does it. It's controlled by the sympathetic nervous system.
Sympathetic nervous system.
Yeah.
That's the fight or flight one, right?
Exactly that. It handles all the automatic stuff, breathing, heart rate, digestion, and that immediate response to perceived threats or intense stimuli.
So how does that system make the bumps happen?
Okay, so at the base of every single hair follicle, you have these tiny, tiny muscles. They're called arrector pili muscles.
Arrector pilis.
Yeah.
Like hair erectors?
Pretty much. And when the sympathetic nervous system sends the signal, maybe because you're cold or scared or hearing amazing music, these little muscles contract.
They tense up.
Yeah, they tighten. And because they're attached to the hair follicle, that contraction pulls the hair so it stands straight up.
Ah, and that pull bunches up the skin around the hair.
Precisely. That little bunching is the bump you see and feel.
Wow. So tiny muscles attached to every hair. That's kind of wild. Does that happen everywhere?
Pretty much anywhere you have hair follicles and these muscles. Arms, legs, neck, even your scalp sometimes. Not places like your palms or the soles of your feet, obviously.
Okay, so that's the how. Tiny muscles pulling hairs up. But why? Why did we evolve this? Feels a bit useless for us humans.
That's the million-dollar question, isn't it? It's definitely an evolutionary hand-me-down.
From when we were furrier.
Exactly. Think about animals with thick coats, dogs, cats, bears. For them, piloerection serves two really clear purposes.
Okay, what are they?
First is insulation. When all that fur stands on end, it traps a thicker layer of air right next to the skin.
Like putting on a puffer jacket.
Kind of, yeah. That trapped air acts as an insulator, helping them stay warmer in the cold.
Makes sense. And the second reason?
Making themselves look bigger. Scarier.
Ah, the Halloween cat effect.
Precisely. When an animal feels threatened, puffing up its fur makes it appear larger and more intimidating to a potential predator or a rival. It's a visual warning signal.
Okay, both make total sense for a furry animal. But for us, my arm hairs standing up aren't going to keep me warm, really.
Not significantly, no.
And I'm definitely not scaring anyone off by looking slightly bumpier.
Chuckles, probably not. And that's the puzzle, isn't it? We've lost most of our body fur, so those original functions are, pretty much obsolete for us.
So why keep their reaction? It seems like a leftover bit of code.
That's what's fascinating. It suggests there might be other reasons, or maybe the system got co-opted for other things, which leads us right into all those other triggers.
Right, the emotional stuff. The sources mentioned quite a few.
Yeah, beyond cold, you get goosebumps from really intense emotions. Fear, obviously, but also shock, anger, awe, even great excitement or joy.
And physical things too, right? Touch.
Definitely. Certain kinds of touch, intimacy, sexual arousal, even being tickled can trigger it.
I get them sometimes just from like a really sudden noise or a jump scare in a film, even if I know it's coming.
Totally normal.
Yeah.
And that specific kind of trigger, the one from external things like music or movies, researchers have a name for it, frisson.
Frisson. Sounds fancy. Like a French shiver.
It basically means aesthetic chills or psychogenic shivers. It's that tingling, sometimes shivery sensation you get from stimuli that aren't about immediate physical danger or temperature.
So listening to an amazing piece of music or watching a really powerful scene, that's frisson.
Exactly. That wave of tingles up your spine or arms. It can happen with powerful speeches, certain visual art, even ASMR for some people.
Someone in the research actually called it a skin orgasm, didn't they?
Laughs. They
Yeah.
did. It's certainly a memorable way to put it, but it does capture that intense, pleasurable, yet involuntary physical reaction some people experience.
Okay, my skin having orgasms is
Huh.
a thought. But seriously, how does that work? How does a beautiful song connect to the same system that's meant to react to, like a predator jumping out? Feels like crossed wires.
It does seem like a mismatch, but the thinking is about how our brain processes unexpected things. The sources talk about this idea of like two brain systems working in parallel.
The old emotional brain and the newer thinking brain.
You got it. The emotional brain, think amygdala limbic system, is ancient. It's super fast, and its main job is survival. It's constantly scanning for anything unusual, anything potentially dangerous.
Like a radar system.
Exactly, like that bunny in the forest, always listening for the snap of a twig. It reacts instantly to sudden changes or unexpected patterns.
So a loud noise, a sudden shift in harmony in music.
To that primal brain, which doesn't understand art or movies, those are just signals that something is different, something unexpected is happening, and its default reaction is potential threat, alert.
Wow. So a powerful chord change could literally trigger a danger signal in that old part of my brain.
In a way, yes. It's the unexpectedness, the deviation that trips the alarm. And that alarm signal goes straight to the sympathetic nervous system.
Which tells the arrector pili muscles.
Contract, prepare for action. And boom, goosebumps. It's the body's instant physical reaction to that potential threat signal.
Okay, but almost immediately, I know it's just music. I'm not actually in danger.
Right. That's where your thinking brain, the prefrontal cortex, and other higher level areas comes in. It catches up very quickly.
It assesses the situation properly.
Yes, it performs what researchers call a cognitive reappraisal. It looks at the context and says, hold on, that wasn't a scream, that was just a high note. We're safe, it's music. Or, that wasn't an attack, that was just a tickle.
False alarm, everyone stand down.
Exactly. The thinking brain overrides the initial panic signal from the emotional brain. The fight or flight response starts to calm down.
But then something else happens, right? Something rewarding.
This is the really cool part. When the thinking brain successfully identifies the threat as benign, when it resolves that initial tension or surprise, your brain releases dopamine.
Dopamine. The feel-good chemical.
Yep, it's like a little reward.
Wait, so evolution is rewarding me with happy juice for figuring out that the sudden loud bit in the movie wasn't a real monster.
That seems to be the theory. It's like your brain says, nice job, you correctly assessed the situation, realized it wasn't dangerous, here's a little dopamine hit for your trouble.
So my body gives me goosebumps at a primal fear from Celine Dion hitting a high note, and then gives me a dopamine reward for realizing it's just Celine Dion and not, I don't know, a pterodactyl screaming.
Laughing. That's a pretty accurate, if slightly absurd, summary. It connects to why we enjoy things with tension and release, scary movies, thrilling music, even tickling to some extent. There's that initial jolt, the primal alert,
Goosebumps.
followed by the cognitive reappraisal, oh, it's okay, and then the pleasurable dopamine release associated with resolving that tension, the joy of figuring it out or surviving the false alarm.
That is genuinely hilarious and makes so much sense.
Right.
Our brains are weird.
Wonderfully weird.
But okay, let's switch gears a bit. Because there's this other reason goosebumps are important, right?
Yeah.
Something newly discovered, linking back to the physical side, the cold response.
Yes, this is really fascinating work coming out of places like Harvard and NIH. They've found a deeper, more functional reason why this whole system might have stuck around, even in relatively hairless humans.
Don't keep me in suspense. What is it?
They figured out that the sympathetic nerve, the same one that triggers the arrector pili muscle to contract and cause the goosebump, it doesn't just talk to the muscle, it also directly connects to and communicates with the hair follicle stem cells.
The stem cells. The ones that actually make the hair grow.
The very same ones. And here's the kicker. The little arrector pili muscle itself plays a crucial role. It's not just the motor, it acts like a physical bridge.
A bridge.
Yeah, it provides the necessary structure, like an anchor point, that allows the nerve fibers to physically reach and connect properly with those stem cells in the follicle niche.
So the muscle has to be there for the nerve to talk to the stem cells correctly.
That's what the research suggests. It's essential for that connection. And what they found is that under prolonged cold, not just a quick shiver, but sustained cold exposure.
Like being outside for a while in winter.
Right. The sympathetic nerve activity ramps up, it gets more active, and it releases more of a neurotransmitter called norepinephrine.
Norepinephrine. That's a stress hormone, isn't it?
It is. And when this norepinephrine is released near the hair follicle stem cells, thanks to that nerve connection supported by the muscle,
Yeah.
it does something crucial. It activates the stem cells.
It wakes them up.
Essentially, yes. It signals them to start proliferating, to regenerate the hair follicle, and over the longer term, to grow new hair.
Whoa. Okay, hold on. So the same system that causes the immediate short-term goosebump reaction to cold
Yes.
is also using that same nerve signal, especially when the cold lasts, to tell the stem cells, hey, it's seriously cold out here. We need a thicker coat. Start growing more hair.
You've nailed it. That's the dual function they uncovered. Goosebumps are the rapid, short-term response, but the underlying nerve activity also triggers the long-term adaptation, stimulating hair growth for better insulation down the line.
That's brilliant. It's a two-pronged strategy. Immediate reaction plus a plan for the future.
Exactly. It turns what looked like a vestigial reflex into part of a really sophisticated, integrated system for regulating body temperature and adapting to the environment over time.
And the muscle is key, not just for the bump, but for enabling that long-term signal.
Right. They even found the whole system develops in a coordinated way. The follicle tells the muscle where to form, and the muscle then attracts the nerve to connect everything up. It's beautifully orchestrated.
Mind blown. Okay, so wrapping this all together, why does understanding all this matter? Beyond just satisfying curiosity about weird skin bumps.
Well, on a basic science level, it's a great example of how different cell types, nerves, muscles, stem cells coordinate and communicate, and how environmental signals like temperature can directly influence fundamental processes like stem cell behavior.
And that specific finding about the muscle bridge and nerve stem cell communication, that sounds like it could have practical uses.
Potentially, yes. Understanding this pathway could be really important for regenerative medicine, especially, as you might guess, for hair loss.
Oh, so.
The sources mention that in common baldness, like male pattern baldness, those tiny arrector pili muscles are often lost along with the hair follicle shrinking.
So if the muscle bridge is gone, the nerve can't properly stimulate the stem cells anymore.
That could be a contributing factor, exactly. So if researchers can figure out how to reactivate those stem cells, maybe by mimicking the nerve signal or finding ways to restore that connection, it could lead to new treatments.
For baldness or maybe even other skin issues. Wound healing.
Possibly. Anywhere that nerve stem cell communication in the skin is important, understanding this mechanism could provide new therapeutic targets. It's early days, but promising.
Amazing. So the solution to hair loss might be hidden in the mechanism behind getting chills during a scary movie.
It's certainly connected in unexpected ways. Now, just a quick medical side note we should touch on. While goosebumps are almost always totally harmless,
Yeah.
very, very rarely, if someone experiences them constantly without any obvious trigger like cold or emotion, it could be linked to an underlying condition. Things like certain skin disorders, maybe anxiety, withdrawal from some substances, or in super rare cases, neurological issues, or something called autonomic dysreflexia.
But that's persistent, unexplained goosebumps, and it's really uncommon.
Exactly. Extremely uncommon. For 99.9% of us, goosebumps are just a normal, everyday physiological response. Nothing to worry about.
Just our body doing its complex, slightly weird, but ultimately fascinating thing.
Precisely.
Wow, what a deep dive.
Mm-hmm.
We went from ancient fur coats and looking scary to emotional roller coasters and dopamine hits from music, all the way to cutting-edge stem cell science and potential hair loss treatments, all packed into that little bump on your skin.
It really shows how interconnected everything is, doesn't it? Nerves, muscles, stem cells, emotions, our evolutionary past, all playing a role in this one simple-seeming reaction.
And sometimes our primal brain gets hilariously confused by art.
Chuckles. That too. It's a great reminder of the layers of complexity hidden within us.
Absolutely. Okay, so here's something for you, our listeners, to think about. The next time you feel those bumps rise on your skin, whether you're cold, scared, moved by a song, whatever it is, just take a second. Remember, you're experiencing this ancient reflex that's not just about the now, but might also be signaling your body to prepare for the future. And maybe your brain is giving you a tiny reward for not panicking. It makes you wonder, doesn't it? What other everyday things our bodies do have these incredible hidden stories and complex mechanisms just waiting to be uncovered?
And that wraps up today's episode of Everyday Explained. We love making sense of the world around you 5 days a week. If you enjoyed today's deep dive, consider subscribing so you don't miss out on our next discovery. I'm Chris, and I'll catch you in the next one.